Okay, so what we are doing over here is that we are continuing with the first part what we are left in understanding what is a derivative. We have already gone through what is a average velocity, instantaneous velocity, but we are just yet to cover the final part which I would like to show you. Okay, so what we have seen over here is that we have deduced this concept that we have taken a graph and we have taken just an arbitrary point which we know, and when we are trying to move this point as close as we can, so we are reducing the value of h. Here, although as per the calculation that we have done it earlier, as you see, we can include x1 plus h minus fx1. So just for the time being, let us ignore x1 so that things look nice. Okay, so here we are. So instantaneous rate of change, what we can write is basically the limit of h moving towards 0. On the numerator, we have got f of x plus h, and this should be whole divided by h, right? And this is what we call the what is derivative. Now, let me use a different color. So in order to use this part repetitively, right? Instantaneous rate of change, instantaneous rate of change, what we can write, this part is what we call, let me put it in this language. This is called the derivative of the function, derivative of the function y, right, with respect to x. So this is what we call the derivative of the function y with respect to x, and then we use the normal equation, this part, right? So if we want to use this as a kind of a notation, so what we are doing is that we are typically using the Leibniz notation, as we have seen earlier in the video, the types of notation that we have. So derivative of the function of y with respect to x can be written as dy by dx. This one again would be equal to the limit of h approaching 0, f of x plus h, or it can be x1 plus h, doesn't matter, minus f of x whole divided by h. Right. So derivative of a function with respect to y, of y with respect to x, this can be also written equal to instantaneous rate of change at that point. And I use a different color. Okay, so now I think that you understood the concept. Now, what is important? Let us go back to this part. What is important? This part, this one which we did, is that what we did? We calculated the normal, the slope equals to rise and run, and we calculated the normal average rate of change. Okay, and we also know that in case of instantaneous rate of change, what we need is a non-uniform motion, right? Say now, for example, if we get this kind of a graph, right, and we are willing to say, if I draw a line even over here, this one connecting with this one, right? So what we are doing essentially is that we are calculating the slope. So the slope of the line. So now you see that when once this becomes the secant line. So I'll just write it as secant line. So we are using the secant line with an approximation that h will come slowly close. So that means the secant line will approach the original, which is the tangent line. So the slope, which is calculated using y2 minus y1 whole divided by x2 minus x1, is basically a kind of an approximation. Why it is an approximation? Why we call it as an approximation is this one. If I take a value and it is coming to the limiting value, which we have taken it as 2, okay, so it can be anything, 1.5, 1.7, 1.8, 1.9, 1.99, it can be anything. So approximation here doesn't work out. So once we are taking the limit of h moving towards 0, that means we are no more using this sign. It will become equal to. So limit of h moving towards 0 with this expression, it becomes equal to the slope of the tangent of a line. And this one is called the instantaneous rate of change. And the instantaneous rate of change can also be written as the derivative of the function y with respect to x, because this is basically the graph we have got, f of x. So when we are taking the derivative of the function y with respect of x, it is equal to the instantaneous rate of change. We use this term dy by dx equals to limit of h moving towards 0. So there are certain points which I would like to make before we end this video. So here is a summary. This is important. So when h becomes smaller, the secant line approaches the tangent line, right? So this is important because the secant line means it is just one line. The tangent line means that we are getting two lines. So when h approaches 0, the secant line, there's a single line, is approaching the tangent line. So we are getting a kind of an exact value. If there is a constant change, instantaneous change doesn't come into play. For that, we have seen this graph. We have seen that graph. Uniform, uniform, and this one is non-uniform. So here only instantaneous rate of change comes into play, right? If we involve any change, then we use calculus. Obviously, if it is something which is regular, straight, we are not using calculus. dy by dx, limit of h moving towards 0 with this expression, can also be written as dy by dx equals to limit of h moving towards 0, delta y by delta x. Why? Because of this. Because y2 minus y1 is a change in y, x2 minus x1 is a change in x. So we use this delta sign for that. dy by dx is the instantaneous rate of change with respect to x, obviously, this part. And at very small values, this is important, dy by dx more or less becomes equal to delta y by delta x. Now there is a last point which is remaining, and after that what we would do is that we would conclude the video. Once we have learned this, we yet do not know like how do we calculate and what are the rules for differentiation. Now you see this one, dy by dx, is what we call differentiation, and there are different rules which I will be making up different videos for this. Now say for example, if you get this kind of an expression, okay, this is a mathematical expression, fx equal to 3x x squared by 12, and we can use this as f prime x, which means actually dy by dx. Okay, so how can we solve this one? F prime x equal to limit of x, and what we do is that we use 3x plus h square, where x equal to x plus h square, plus 12 fx. So it is 3x squared plus 12, this one, plus 12 minus this one, f of x, which is 3x squared by 12. So what I can do is that I can quickly solve this equation, and I will show you the result and what is the underlying meaning. So if I go forward with that, what I will get is that I'm using a different pen. So limit of h moving towards 0, and if I expand this equation, so the numerator becomes 3x squared plus 6xh plus 3h squared plus 12 minus 3x squared minus 12 whole divided by h. And what we see is that this one gets cancelled out, this one gets cancelled out. What else? Yeah, that is out. So, and this one gets cancelled out, and this one, right? So what is remaining over here is that I write limit of h moving towards 0, and on the numerator what we get is 3h 2x plus h whole divided by h. So I'm rewriting it once more. So this h gets cancelled out, right? So this is the top one which got cancelled out. So I can write limit of h moving towards 0. Then I can use this multiplication as 6x plus h So this would be the final expression. And now I will use a different pen for this. If I make, because h is moving towards 0, I use h equals to 0. H equals to 0. So the limit of h, so what is the final result? That if I substitute now for 0, so what I get is that limit of h moving towards 0 is equal to 6x. Right. So the derivative of the function fx 3x squared plus 12, this expression, this particular expression, this becomes equals to 6x. Right. So the slope, so from here what I can do is that I can write the slope would be the number from 6x. So if you're calculating a kind of this kind of a slope or something, it would always have this value of 6x, right? Now you see this is not a rigorous method actually. So I have opened this, expanded, and I've substituted this one, and I have cancelled, and I have shown this one. But there are other ways in which we can calculate, and that would be the topic of our next video. So this is just a kind of a very basic explanation in order to use this rule which we have learned of limit in the last video, how we can solve it. So whatever the slope we are calculating, we are getting it from the previous value, that is the value from 6x. So this actually brings to the end of our video. And before we wrap up, I would just like to quickly draw a few points before we close for this, because it has been divided into two parts, the first one and the second. Just keep a note on the difference between instantaneous velocity and average velocity. So the basic key point is that distance covered in a unit time is called average speed, and the distance covered is called in a single moment of time is basically what we call is an instantaneous speed. Remember this graph where the speedometer is always pointing out a specific point. It can be t equals to 5 or 8. This is instantaneous speed. Remember this picture also, where it shows a continuous flow or a change, and this is the average. But if we try to fix up or pick up a single point, then obviously that becomes the instantaneous rate of change. The instantaneous rate of change is denoted over here, where we always try to get close of this original value, that is the limiting value, right? And if we get one particular point, the problem starts from here. That if we get any one point, and if you're going close to the second point, what we are doing is just we are making an approximation. So what we are doing is we are making an approximation. Because we are making an approximation never works in mathematics, and that is the reason that we use this formula. We are using this formula. So we are taking one point, we are substituting the values of x, and as on when we are getting closer and closer and closer to that value, so this one, which is the key one, this particular sign is being replaced by this particular sign. So it is no more an approximation. Why it is no more approximation? Because we are taking the limit of h, which is moving towards 0. That means it is exact. It is infinitesimally small. So this instantaneous rate of change is the limit of h approaching 0. And this instantaneous rate of change is called the derivative, which is the crux of this video. And this is the instantaneous rate of change of point. Because we cannot write this literal in English term, we are using dy by dx. So finally, just to show you the summary, is that this one. When h becomes smaller, the secant line approaches the tangent line. Obviously, because as h is becoming smaller, the secant line is approaching the original tangent line. If there is a constant change, instantaneous change does not come into play. Yes, because it is all rectilinear motion. If we involve calculus, then only a change, then only calculus happens. dy by dx is basically again the derivative of the function y with respect to x. This is actually the instantaneous rate of change, this part. Instantaneous rate of change. Why? Because we are picking up a single point in the graph. Remember, this one. We are picking up just a random point. And we don't have another point. So we are making the point close and close and close and close to this. So this particular notation, limit of x, this can be also written as dy by dx limit of h moving towards 0, because this part is basically this part, y2 minus y1. dy by dx is the instantaneous rate of change of y with respect to x, and at very small values dy by dx is more or less equivalent or equal to delta y by delta x. That is what is the concept of derivative. I hope that you liked it, and just keep a note on what we discussed. The two major difference, instantaneous rate of change and average rate of change. That is the crux of the concept of derivative. In the next video, I will be putting up more on the formulas that we have in derivative and small mathematical equations, problems, where we can calculate using that derivative formula. What we showed over here, the 3x squared plus 12, that one is not a very rigorous method. That one is actually an algebraic method in which I have shown how you can calculate the value. But that is not. We have different other methods which will be discussed in the next part of my video. So this is actually not a very rigorous method. So just watch out my next video where I will be discussing about the rules of differentiation and how do we take a derivative. So derivative is the act, derivative is the concept, where we calculate the instantaneous rate of change, and differentiation is the act. So you can call differentiation is basically the verb, the act to do, and derivative is the concept. Hope you liked it, and watch out my next videos where more formulas of derivative equations are coming up. Please do like, please do share, and please do put up your comments. And subscribe to my channel, which will help me grow, motivate, and make more videos. Hope you liked it. So this concludes the second part. The first part ended abruptly a little bit, and this is the continuation. Thank you very much. Keep safe, keep happy, maintain social distance, and wish you a very happy day ahead. Goodbye.